Welcome back, folks. Today, our target is to determine the polarity of a molecule based on the difference in electronegativity and shape. So, it's a fairly wordy target. Let's just kind of break down what some of those words mean. First of all, polarity. Polarity is just a molecule with a difference in charges. So we know that molecules have electrons. And if certain parts of that molecule have a lot of electrons and other parts of the molecule don't have a lot of electrons, that molecule is polar because there's a difference in charges. So today we're going to determine if something has a difference in charges based off of the difference in electronegativity, okay, how badly it wants electrons, and its shape. Okay, so first of all, let's just talk about this first one. How can we tell if a molecule is polar based off the difference in electronegativity? Okay, we use a table. Actually, we use two tables. See, all elements have an electronegativity, and we can figure that out using, you guessed it, our handy-dandy periodic table of elements. See, every single element in the periodic table has an electronegativity value we can use. You do not need to memorize any of these values. They will always be provided. You do need to memorize this secondary table because it's so much more smaller and it's not too bad. But basically, if there is a difference in electronegativity in between what we would refer to as 0 to 0.4, it is what we would refer to as non-polar. If there's a difference in electronegativity between 0.41 and 1, it is slightly polar. And if there's a difference in electronegativity of 1 and 2, it's polar. So real quick, let me just give you some electronegativities for a couple of different elements and we'll see if they're polar or non-polar. Hydrogen. It's got an electronegativity of 2.1. Carbon's electronegativity is 2.5. We've got oxygen, which has an electronegativity of 3.5. And we've got fluorine, which has an electronegativity of 4. Okay. So let's just kind of look at a couple of different bonds to see if these bonds would typically be polar or non-polar. Basically, is there an unbalanced charge on one of the two atoms? So let's just say, for example, I've got a carbon atom and a hydrogen atom. Well, carbon has an electronegativity of 2.5 and hydrogen has an electronegativity of 2.1. So if I find the difference between these two values, I get an electronegativity of 0.4, which if I check out my handy-dandy little table, I would see that typically carbon and hydrogen bonds are non-polar. Okay, you try one. Let's say we've got a carbon bond and it's connected to fluorine. Would that be polar, non-polar, slightly polar? Pause the video, see if you can figure it out. All right. So now that you've finished trying to figure out if this is polar or non-polar, let's see. We know that, fluorine's got an electronegativity of 4.0, carbon's got an electronegativity of 2.5. So if we subtract those two values, we get a difference in electronegativity of 1.5. Meaning that typically carbon and fluorine bonds are going to form polar molecules because 1.5 is in between 1.01 and 2. So it's polar. There you go.